In this video, we're going to take a look at setting up networking interfaces for use with iSCSI in a fault-tolerant load balancing way, and we're also going to look at configuring the software iSCSI initiator. You may actually be using an iSCSI hardware initiator and you have a NIC that has specialized functionality for iSCSI, and that will potentially let us do things like boot from iSCSI or, potentially using a fiber channel HBA that does something similar, and oftentimes will support various offload features. When we look at using iSCSI compared to low latency protocol that runs over fiber and over a switched infrastructure, there's no concept of routing. There's very little in terms of things like congestion control and sliding windows and so on, where TCP/IP tries to adapt itself to, links of better capacity or higher latency or higher error rates and things like that. A lot of those things work very, very well when we're doing small scale operations from one system to another. When we try to do the sort of heavy I/O operations, then the overhead that TCP/IP and Ethernet come with is significant, and we may need to optimize that somehow. So using a hardware iSCSI initiator that has those offload features is good. We may also be looking at things like jumbo frames. Normally, a TCP/IP packet has the maximum transmission unit size, 1500 bytes. We can increase that potentially, if all of our equipment supports it. We could increase that up to 9000 bytes. And there's going to be just fewer packets to keep track of, fewer fragmentations and reassemblies and all these other things to do. So what ideally our iSCSI network would look like is much like our fiber channel network, a flat infrastructure with switching but no routing and so on. And then we can optimize for that. So we're definitely going to want to use specific dedicated NICs to do this, or specific VLANs potentially. If we're using something like 10 gigabit Ethernet, then maybe we're going to combine this traffic with other types of traffic. Certainly we're going to need to do things like configure VM kernel ports. One of the major differences, though, with iSCSI compared to, say, NFS is that NFS supports NIC teaming, but iSCSI does not. So even though, for example, here, if we look at my network configuration on vSwitch 1, which I was using to access my NFS storage, I specified one IP address and just associated a couple of NICs with it and did the standard network teaming. What we'll see is for the network infrastructure I've set up for iSCSI, it really doesn't work that way. We've got two addresses locally. We've also got two addresses on the server, and potentially we may need more. If I want to use 4 or 5 or 6 NICs to establish very high-speed iSCSI communications, I'm going to need 4 or 5 or 6 IP addresses. So every interface needs to have its own IP address. Conceivably, we could create many vSwitches to do that, but in this case, I've created 2 VM kernel ports with one vSwitch. What I really need to do is associate one of these NICs to one of these addresses. And again, it might be better to just have a port with a vSwitch with one adapter, but if we take a look at what I've done here, we'll see the recommended configuration from VMware. So if I go into the properties, you can see that I've got my VM kernel iSCSI A, and it's got an address of 172.16.50.110. My MTU is 1500. Like I said, we might be able to increase that if we have support for jumbo frames everywhere. And I've got my iSCSI B, same configuration, but .111. But if we access the properties of those VM kernel ports, we can see for NIC teaming, rather than using the 2 adapters as active, I've got one marked as active and one marked as unused, not even in standby. And for the other, I've got the exact same configuration, but the NIC's roles are reversed, and one's active and one is just unused completely. So it's going to be the responsibility of the iSCSI software initiator to figure out what paths it should use and how it should be doing its load balancing. We just need to make sure that there's enough communication channels available for it to be able to do that. Now, again, we could have definitely done this as, separate vSwitches, separate VM kernel ports, and separate NICs associated as the uplinks to those vSwitches. In this case, just to keep the configuration a little bit more straightforward and to see that it's all logically grouped together, I've got one vSwitch, 2 kernel ports, and 2 NICs. So the diagram doesn't really reflect the association between those port groups and those NICs the way that I've set it up that way. So that's all fairly standard. I mean, we would do it in a reasonably typical way. It's just that rather than adding the VM kernel port once and then changing the NIC bindings and the failover modes and the teaming modes for NFS, we're going to add 2 VM kernel ports, and then we're going to go in their properties and associate the correct NICs with them. So this can all get a little tricky. It also causes some challenges potentially on the remote side when our iSCSI target server has many IP addresses available as well. Now, the iSCSI protocol does have a means through what's called portal mode to basically discover all the paths available to the storage. So we typically only need to provide one address in order to connect to the iSCSI storage, but what we may find is that it comes back and discovers the other addresses. So it's very important that just like we have one address per channel here that we want to use, that storage backend also matches that configuration. So let's take a look at setting up software iSCSI initiator. So now that I have the NICs in place with the right IP configurations, let's head over to storage adapters. So in this case, we can see that the iSCSI software adapter is already listed. That's not necessarily going to be the case. And if I go to my other server, we can see that it's not listed. If I wanted to add it, I just click add, and there's an option to add the software iSCSI adapter. Or I believe this requires Enterprise Plus. There's also a fiber channel over Ethernet adapter. With fiber channel, we have very low latency and, this dedicated fiber network and a pretty optimized environment for accessing local storage. But again, that's a completely different infrastructure than you already have for the rest of your network. So if you don't want to run special cabling, if you don't want to have specialized switches, then what you may want to do is run the fiber channel protocol over Ethernet. Common cabling, common switches, but no TCP/IP actually. So it's SCSI directly over Ethernet rather than SCSI over TCP/IP over Ethernet the way iSCSI is. So that could still be a viable solution. So if I want to say add a software iSCSI adapter, I can do that and says, okay, well, no problem, but we're going to have to go in and actually configure it. Let's do that on my original server. I already set it up. If I go into the properties, there's a few things that we had to do. If I click into CHAP here, my iSCSI target is going to require some form of authentication so that no one can go in and access the disks. Typically, we'd use usernames and passwords and things like that, but we don't have support for that in iSCSI. It's much more like how we authenticate a dial-up connection, actually, using the same challenge authentication response. If we need to do that anyway, we'll provide the passwords here. This can actually go in both directions. The server can authenticate the client, and the client can also authenticate the server. Now, I've set this up on its own private VLAN, and I'm not really worried that someone's going to go in and access it. So I'm just going to say not to do that. Or we may have to do that on a target-by-target basis. Rather than setting global settings here, we may have to set them up on a case-by-case basis. If we go into the advanced, there's various other options we can turn on here. So if you need to do something to improve compatibility or to troubleshoot some issues with your storage, we can go in and do this here. But you're really going to have to consult the VMware Storage Config Guide, and particularly whatever documentation your vendor has as to what options we should really be using here. So if we click over to network configuration, the main thing that we need to do is specify which network interfaces are going to be used for iSCSI. And this is something that we don't have to do for NFS. It just uses whatever the routing would normally use on a local server. With vMotion, we actually have to go into the VM kernel properties and say, I want to use this virtual interface for vMotion, or for fault tolerance, or just for management traffic in general. But for iSCSI, we actually need to add them. In this case, they've already been added, but I would just say add all the NICs that are not already associated somewhere else. I can select them and make use of them. And then I need to actually provide some details of the server side. In this case, I've set up iSCSI using the Microsoft iSCSI Software Target 3.3 running on my domain controller. Now I set up some specialized addresses for this. I don't want to route it over the same network that I actually use for Active Directory and so on. So I set up some additional NICs in that virtual machine, which is actually running outside of my ESXi environment, inside my VMware Workstation environment. Set up a few extra NICs on that virtual machine. And inside the iSCSI software properties, I said only accept, only bind to the specific adapters I wanted to use this for. So it's got a couple of addresses. It's got 172.1650.21, but it's also got 172.1650.22. But I didn't need to provide that here. All I did was click add, provided the name or the IP address of the iSCSI server, the port if it's been customized. So over on the Dynamic Discovery tab, we can actually specify the target details for iSCSI. I've actually set up iSCSI on my domain controller, which is another virtual machine running at the same level as my ESXi hosts in VMware Workstation. 3 interfaces on that machine, one that I'm using for actual Active Directory traffic, the 2 other interfaces that I'm going to use for iSCSI. So those are 172.1650.21, but also 172.1650.22. Now I didn't add both of them. I just provided one here. And depending on what your storage supports, ideally if it's running in portal mode, we'll come back and tell you all of its other IP addresses. So I just provided one. If I click add here, I can just provide the iSCSI IP or the name, change the port if I need to, and set up different authentication options for CHAP if I don't want to use the global settings. So when I provided the one address, it actually came back with the remaining addresses as well. So if I go over to static discovery, I can see that it actually came back with 21 and 22. I didn't have to add those. If our array didn't support that portal mode and didn't return those extra addresses, then we'd have to use add to add all the paths to that iSCSI storage manually. And we need to make sure that each interface on the iSCSI server that we want to use as a communication channel anyway has a proper IP address bound to it. There's no support for NIC teaming in iSCSI, so we can't take advantage of that. Now, if I look through the details section down in the lower area, we can actually see the disks that have been presented from there. So we can see that I actually have a couple of devices, but you'll notice it says I've got 4 connected targets and 8 paths available. I have 2 local addresses, there's 2 remote addresses, and if we do all the math between them, that combines into potentially 8 paths. Although that really depends, I think, on whether we have multiple switches or not, and so on. We really should try to think of the number of logical paths, but also make sure that those physical paths are as highly redundant as possible and as isolated from each other as possible in terms of failures affecting one versus the other. If I click over onto paths here, we can actually see the different paths available, and we can also see what their state is in terms of being active or not. We're going to talk about that in another video, and we're going to take a look at multipathing and path selection, and we'll also talk a little bit about storage array types, path selection policies, and how to configure those in both the GUI and in the shell.